Hey everyone, and welcome back to the deep dive. Today we're going deep into shell scripting for DevOps.
Ooh, that's a good one.
Yeah, it's one of those essential skills, right? But it can be a little intimidating for newcomers.
It definitely can.
So we're going to break it down, make it approachable, and we're going to focus on those tricky interview questions you might face.
We're going to cover everything from the very basics of what a shell script is all the way to how it plays a part in those CI/CD pipelines.
Exactly. And
Get it?
hopefully help you not just survive, but really ace those interviews.
That's the goal.
All right, so for me, I've always found the whole concept of a shell script a bit mysterious.
Oh, yeah. How so?
Well, it's just a text file, right?
Right.
But somehow it can like control my entire system.
Yeah.
It's like magic or something.
It is kind of magical when you think about it. It's basically a way to talk directly to the heart of your operating system, the shell.
Yeah.
You give it a set of instructions in a language it understands, and boom, it goes off and does its thing.
So it's like a recipe for automation.
Exactly. You're automating those repetitive tasks, those things you'd normally do manually.
But there are so many different shells out there. Bash, Zesh, Karish? Is there a best one for DevOps?
It's less about finding the best and more about choosing the right tool for the job.
Okay.
Bash is incredibly common and a great place to start. But as you get more comfortable branching out and exploring other shells can really expand your scripting possibilities.
Flexibility is key.
Gotcha.
So let's say I've written my first script. It's a masterpiece of automation. How do I actually make it run?
You need to give it permission to execute. The chmod plus X command is like flipping a switch, giving your script the power to run.
Oh, so that little command is what unlocks the potential.
It is. It tells the system, hey, this isn't just a plain text file. This is a program ready to do some work.
That's cool. So once we've given it permission, how do we tell it to do something, like the classic hello world example?
The echo command is your friend there. It's the simplest way to make your script output some text.
Okay, so echo hello world, and I'll just print that out.
Exactly. It's the foundation of all scripting greatness. You can use it to print messages to the console, log information to a file, or even send notifications.
All right. I can already see how useful that would be. But let's say we need our script to remember something, like the name of a server or a file path. How do we give our scripts a memory?
That's where variables come in. They're like containers for storing information within your script.
Okay, so like labeling a box and putting information inside.
You got it. For example, you might store the server's IP address in a variable called server IP and use that throughout your script.
So variables help us organize and reuse information within our scripts.
Exactly. They make your scripts much more flexible and powerful.
But are there any rules we need to be careful about when using variables? Anything that might trip us up?
One crucial thing is spacing. When assigning a value to a variable, make sure there are no spaces around the equal sign.
No spaces around the equal sign. Got it.
Yeah.
Any other gotchas?
Be mindful of how you name your variables. Keep them descriptive and avoid using reserved keywords or special characters.
Good advice. So we've defined our variable, our box, and filled it with information. How do we actually access that information when we need it later?
To use a variable's value, you simply put a $sign in front of its name.
So server IP would give us the IP address we stored earlier.
Precisely. It's like saying, hey, script, fetch me the contents of this box.
That makes sense. So we've covered variables, but what about those system-wide settings that apply to all processes? Are those also variables?
Absolutely. Those are called environment variables. They're like the global settings for your system.
Yeah.
Things like the path variable, which tells the shell where to look for executable files, or the home variable, which points to your home directory.
Interesting. So if we want to share a variable we create with other processes, can we just add it to those environment variables?
You can. The export command lets you share your variables with child processes. Think of it like passing down information from parent to child.
Okay, that makes sense. So far, we've talked about words and variables. But what about doing calculations or comparisons? Can shell scripts handle that too?
Oh, definitely. That's where operators come in. They let you manipulate data, perform arithmetic, and make logical decisions.
Operators. Sounds intriguing. What kind of operators are we talking about?
There are arithmetic operators for math relational operators for comparisons, logical operators for combining conditions, and even string operators for working with text.
So with these operators, we can do things like check if a file is bigger than another, or add two numbers together, or even see if a certain condition is true or false.
You got it. They're the building blocks for creating logic and decision-making within your scripts.
Wow, so we're already moving beyond simple commands and into the realm of real programming.
We are, and that opens up a whole world of possibilities for what you can achieve with shell scripting.
I'm excited to see where this goes. But what if we want our script to be a bit smarter and make decisions based on certain conditions? Like, if this happens, then do that. Otherwise, do something else. Is that even possible?
Absolutely. That's where conditional statements come in. They're like the brains of your script, allowing it to make choices and take different actions based on certain conditions.
Okay, so we're giving our scripts the power of logic. I'm all for that.
The if-else statement is the most common one. You use it to check if condition is true and then execute a block of code if it is. If not, it can execute a different block of code.
So it's like a choose-your-own-adventure for our scripts.
Exactly. You can have your script check if a file exists, and if it does, process it in a certain way. If not, it could create the file or log an error.
Okay, that makes sense.
Yeah.
But what if we have multiple conditions to check? Not just a simple yes or no.
If you're dealing with multiple possibilities based on a single value, the case statement can be more elegant. It's like a multi-way switch directing the script to the appropriate code block based on the value.
So instead of a bunch of nested if-else statements, we can use case to handle multiple scenarios more cleanly.
Exactly. It makes your code more readable and easier to maintain.
Okay, so we've got our conditional statements figured out.
Yeah.
But what about those situations where we need to repeat a task multiple times? Do we just copy and paste the same lines of code over and over again?
You could, but there's a much more efficient and elegant way. Loops.
Loops. I've heard of those.
They allow you to execute a block of code repeatedly, either a set number of times or until a specific condition is met.
So this is where real automation kicks in, right? No more manual repetition.
I got it. Loops are essential for any task that involves repetition, whether it's processing a list of files, sending out email notifications, or monitoring system processes.
Okay, so loops save us from a lot of tedious work. I'm on board with that. But as our scripts get more complex with loops and conditional statements and all these variables, how do we keep things organized?
That's where functions come in handy. They're like mini programs within your script.
Okay.
You can group a set of commands into a function, give it a name, and then call that function whenever you need to execute those commands.
So it's like having a reusable chunk of code that we can call upon whenever we need it.
Exactly. Functions make your scripts more modular, reusable, and easier to understand.
I like the sound of that. So we can create a function to say back up a file, and then call that function whenever we need to back up a different file.
You got it. And to make functions even more powerful, you can pass arguments to them.
Arguments, like
Yeah.
giving the function specific instructions.
Precisely. You can pass values to a function, and it can use those values to perform its task.
So we could have a function to deploy code and pass the server name and the file path as arguments.
Exactly. It makes your functions much more versatile and adaptable.
Okay, functions with arguments. That's powerful stuff. But speaking of files, we can't forget about those, right?
Yeah.
How do shell scripts actually interact with files?
File handling is a fundamental part of shell scripting. You can read from files, write to files, check if they exist, and even manipulate their contents.
So it's like our scripts can actually interact with the file system.
They can. And there are lots of commands and techniques for doing so effectively.
Okay, so we can use shell scripts to say, read a configuration file or write log messages to a file.
You got it. And those are just basic examples. The possibilities are endless when it comes to file handling and shell scripts.
I can already see how powerful this is.
Yeah.
But what happens when things go wrong? We're all human. We make mistakes. How do we actually debug our shell scripts when they don't behave as expected?
Debugging is an essential skill for any programmer, and shell scripting provides some handy tools for tracking down those pesky bugs.
So there's a way to figure out what our script is actually doing step by step.
There is. The MassX option is your best friend when it comes to debugging. It shows you each command as it's being executed and the values of all the variables.
So like a behind-the-scenes look at how our script is working.
It is, and it can be incredibly helpful for pinpointing those logic errors or unexpected variable assignments.
Okay, with debugging sorted out, I think we've laid a pretty solid foundation for shell scripting basics. We've covered commands, variables, operators, conditional statements, loops, functions, and even touched on file handling and debugging. But how do we take all of this knowledge and apply it to real-world DevOps situations? Like, how can we use shell scripting to automate things like deployments, server management, or even infrastructure monitoring? That's what I'm really excited to explore.
You're in for a treat. In the next part, we'll dive into those practical applications and see how shell scripting can truly become your superpower in the world of DevOps.
Okay, I cannot wait. All right, so we're back and ready to put these shell scripting skills to the test. I'm ready to automate all the things.
That's the spirit. Let's start with a classic DevOps challenge, backups.
Okay, backups, essential but not always the most exciting topic.
True, but imagine this. You have a script that automatically backs up your critical data every night. Databases, config files, the whole shebang.
Okay, that does sound pretty handy. No more scrambling when disaster strikes.
Exactly. And you can even get fancy with it, add versioning, so you can roll back to specific points in time.
Versioning, so like having a time machine for my data.
Exactly. You'd never have to worry about losing important data again.
That's awesome. Okay, so we've got backups covered. What about managing those servers that are holding all this precious data?
Shell scripting can be a lifesaver for server management, too. Think about all those tasks you do manually, checking disk space, restarting services, updating software.
Yeah, it can get pretty tedious, especially if you're managing a lot of servers.
Exactly. But with shell scripts, you can automate all of that.
So instead of logging into each server individually, we could have a script that does it all for us.
You got it. You could have a script that checks disk space on all your servers and sends you an alert if any of them are running low.
That would be so helpful. And what about applying security patches or updating software packages?
You can automate that too. Imagine a script that automatically updates all your servers with the latest security patches, keeping them safe and sound.
Okay, we're talking about a serious time saver here. It's like having a whole team of sysadmins working 24/7.
That's the power of automation. But we're not done yet. What about monitoring those servers?
Monitoring, yeah, keeping an eye on things and making sure everything's running smoothly.
Shell scripts can help you there too. You can write scripts that constantly monitor system performance, things like CPU usage, memory consumption, network latency.
So we can have our scripts be proactive and catch potential issues before they become major problems.
Exactly. And if anything looks suspicious, your script can send you an alert so you can intervene before it's too late.
That's awesome. So our scripts are like our own personal watchdogs, always on the lookout for trouble.
You got it. But we've only scratched the surface. There's so much more we can do with shell scripting.
Oh, I'm all ears. What other shell scripting magic do you have up your sleeve?
Well, let's talk about something called regular expressions.
Regular expressions. Those sound a bit intimidating.
They can be, but they're incredibly powerful for pattern matching and manipulating text.
Okay, I'm listening.
Imagine you're troubleshooting a server issue, and you have to go through gigabytes of log files.
Yeah, that sounds fun. Naughty.
With regular expressions, you can search for specific patterns like error messages or suspicious IP addresses with laser precision.
So instead of manually scanning through all those logs, we could have a script that does it for us.
Exactly. Regular expressions can save you hours of time and frustration.
Okay, I'm starting to see the appeal of regular expressions. But once we found the text we need, what then?
That's where another powerful tool comes in.
Oh, what's that?
It's like a supercharged find and replace tool. You can use it to make precise changes to text, like substituting strings, deleting lines, inserting text, and much more.
So we can use SOE to clean up data format logs or even generate reports.
You got it. Cells is like a Swiss Army knife for text manipulation.
This is amazing. But so far, we've mostly been talking about working with text. What about more structured data, like spreadsheets or databases? Can shell scripts handle that too?
Of course. That's where awk comes in. It's like having a mini spreadsheet program right inside your terminal.
Okay, you've piqued my interest. Tell me more about awk.
You can use awk to extract specific fields from data perform calculations, filter rows, and much more. It's incredibly powerful for working with structured data.
Wow, it sounds like there's a shell scripting tool for everything. But with so many tools and techniques, how do we keep our scripts organized and maintainable, especially as they grow larger and more complex?
Modularity is key. We talked about functions earlier, which are a great way to break down your code into reusable chunks. But you can take it even further.
Okay, how so?
Think about breaking down your scripts into separate modules, each with its own specific purpose. You can store those modules in separate files and then call them from your main script.
So it's like having a well-organized toolbox where each tool has its place.
Exactly. It makes your code much easier to read, understand, and maintain.
Okay, modularity, I'll keep that in mind. But with all these tools and techniques at our disposal, where do we go from here? How do we integrate shell scripting into the bigger picture of DevOps workflows?
That brings us to the next level, CI/CD.
CI/CD. Now we're talking. I'm excited to see how shell scripting fits into that world. Okay, so we're back ready to tackle CI/CD and see how shell scripting fits into this whole world of automation.
This is where it all comes together. You've got your code, your tests, your deployments all flowing smoothly from development to production.
Yeah, it sounds amazing in theory, But how does shell scripting actually make it happen?
Think of your CI/CD pipeline as a series of steps. Each step is like a task that needs to be done. Build the code, run the test, deploy to staging, and so on.
Okay.
And each of those steps can be automated using shell scripts.
So our scripts are basically the building blocks of the CI/CD pipeline.
Exactly. They're the instructions that tell the system what to do at each stage.
But there are so many different CI/CD tools out there. Jenkins, GitLab, CI/CD, Circle, CI. Do we need to learn a whole new set of commands for each one?
No, that's the beauty of it. Shell scripting is like a universal language that works across all these different platforms.
So the scripts we write can be used with any CI/CD tool.
Pretty much. While each tool has its own way of configuring things, they all ultimately rely on executing shell commands under the hood.
So we can write our scripts once and reuse them across different projects and different CI/CD systems.
Exactly. It makes you super adaptable as a DevOps engineer.
I like that. But as our pipelines get more complex, how do we make sure our shell scripts can keep up? How do we make sure they're efficient and reliable and secure?
That's where performance optimization testing and security best practices come into play.
Okay, so it's not just about writing the scripts, it's about writing them well.
Exactly. You want your scripts to be fast, reliable, and secured, especially in a CI/CD environment where things are automated.
Right, so where do we even start with performance optimization?
One key principle is minimizing external commands. Each time your script calls an external command, it creates a new process, which adds overhead. Yeah, it means it takes more time and resources to execute. If you can do something using built-in shell features, it'll usually be much faster.
So it's like streamlining the script, reducing those extra steps.
Exactly. And another important area is input-output optimization.
Input-output, you mean reading and writing files?
Yep, those operations can be slow, especially if you're dealing with large files.
Mm-hmm.
Try to buffer your input-output so you're processing larger chunks of data at once.
Okay, so instead of reading line by line, we read a whole block of text at a time.
Right. It reduces the number of times you have to access the disk, which can be a big bottleneck.
Makes sense. Any other performance tips?
Take advantage of command piping and redirection. Instead of creating temporary files, you can pipe the output of one command directly into the input of another.
So it's like creating an assembly line where the output of one step becomes the input of the next.
Exactly. It keeps things flowing smoothly and efficiently.
Okay, I'm starting to see how we can optimize for performance, but how do we know where the bottlenecks are in the first place?
There are profiling tools that can help you measure how long different parts of your script take to execute.
Profiling. So it's like having a stopwatch for our code.
You got it. It shows you which parts are taking the most time so you can focus your optimization efforts there.
That's really helpful. But even with the most optimized scripts, things can still go wrong. How do we approach testing to make sure our scripts actually do what they're supposed to do?
Testing is crucial, especially in a CI/CD environment where you're relying on automation. You don't want a buggy script bringing down your entire pipeline.
Right. So how do we test shell scripts?
One approach is to use assertions within your scripts. Assertions are basically checks that certain conditions are met.
Okay.
Like if you're expecting a file to exist after a certain step, you can add an assertion to check that.
So it's like a safety net, making sure things are going as planned.
Exactly. And you can also create separate test suites that run your script with different inputs and verify the outputs.
So we can test different scenarios and make sure our script handles them correctly.
Yep. It helps you catch those edge cases and unexpected behaviors.
Okay, testing is super important. But what about security? Especially when our scripts are automating critical tasks and accessing sensitive systems.
Security is paramount. One common mistake is using user input directly in your scripts without validation.
Okay, what's wrong with that?
Well, if a malicious user manages to inject some bad code into your script, it could potentially wreak havoc on your system.
That sounds scary, so how do we prevent that?
Always validate and sanitize any user input before using it in your scripts. Make sure it's in the expected format and doesn't contain any dangerous characters.
So it's like filtering out the bad stuff before it gets a chance to do any harm.
Exactly. And another important principle is least privilege. Only give your scripts the minimum permissions they need to do their job.
So don't run everything as root unless it's absolutely necessary.
Right. It limits the potential damage if something goes wrong.
Makes sense. Any other security tips?
Store your scripts securely, especially if they contain sensitive information, and keep them up to date. Security vulnerabilities are always being discovered, so patching your systems is crucial.
Okay, patching and secure storage. Got it.
Mm-hmm.
Is there anything else we should keep in mind when writing shell scripts for CI/CD?
Don't forget about documentation.
Ah, documentation, the bane of every programmer's existence.
But it's so important. Clear, concise documentation makes your scripts easier to understand, maintain, and troubleshoot.
Yeah, I guess that makes sense.
Yeah.
Especially if other people are going to be using or modifying your scripts.
Exactly. It's like leaving a trail of breadcrumbs for others to follow.
Okay, I'm convinced documentation is important. Well, this has been an incredible journey. We've gone from the basics of shell scripting all the way to advanced techniques, CI/CD, integration, performance optimization, testing, and security.
It's been quite a deep dive.
It has. I feel like I've learned so much. Thank you so much for sharing your expertise.
My pleasure. And remember, this is just the beginning. Keep exploring, keep practicing, and keep automating.
That's a wrap on this episode of The Deep Dive. Until next time, keep learning and keep diving deep into the world of technology.